Good morning and welcome to Module 3 of the Humanity Environmental Education's AI course. My name is Lee Mallon and I'll be your host, your guide along this course. Today in this program, we're going to be learning our AI fundamentals. So this is just a bit of a primer to what artificial intelligence is, a lot of the buzzwords, and how we can use it in our desire to better storytell and educate on our course. Now, this particular module is split into 5 simple sections. I'm going to give you a bit of a history lesson, show you some terms, what's important, and then delve into generative AI, which is basically the main reason we're here, and how we can use this AI to generate things rather than predict things. And then I'll show you one example I did recently for COP28, and then we'll finish off with just some ethical points that we should bear in mind when we're creating and using this technology. So first up, the history. Technology, like anything, has been around, for most of the century. Artificial intelligence took a massive uptick, or machine learning, as it became known. Obviously, post-war with the Enigma machine and code breaking. Obviously, a lot of stuff from the UK in particular. But it was only when we kind of hit the 90s and the 2010s, the last 30 years, that things really took a step up, because the AI industry or the AI sector tends to run with massive progress for 10 years and then 10 years of nothing, a nuclear kind of winter, and then 10 years of progress. And this is repeated over the last 60 years. But we're hitting a very delicate point now where in the 90s, we started to massively use compute. Everyone got computers and it became kind of commonplace. Then in the 2000s, after the kind of dot-com bust and the rise of Web 2, we started to move a lot of that stuff to the cloud, to centralized compute. And then obviously over the last 10 years, we've just all been giving our data to social media companies freely. And if you pull all these things together, the centralized compute in data centers, the massive rise of a thing called GPUs that started out in games consoles, and they've become an underpinning for training and using for inference in the AI world through a massive, the leading company called NVIDIA in that space. And then if you add into that the fact that we now have centralized a lot of data through tagging photos, uploading, sharing our thoughts on Twitter, and etc. across all these social media companies, we've given these companies resources to train at such a large scale to potentially find patterns and value, etc. And now we both, I guess, are suffering from that decision and also are now reaping the benefits with regards to having massively enhanced and more humanistic artificial intelligence. Now, you may or may not, this may be your first encounter of AI, this may be something that you've been looking into for a while, but there's a lot of terminology in the space, a lot of academic kind of references. But the key is, if you've seen these types of terms that I'm kind of showing on the screen, don't worry too much. They are massively not important if you are looking to just use AI to enhance your workflow or to better storytelling, create things. The key thing to remember is these 4 pieces, which is data, code, relationships, and decisions. So any AI model needs data. It needs something to base its assumptions on. And then once it has that data, it has some code, and that code basically interrogates the data and it finds relationships. It finds patterns between, say, numbers or between words. And then off the back of that, it then makes a decision. And that decision may be, from the data you've given me, I'm 97% sure that this email is spam. Or it might be, from the data you've trained me on, I'm now going to tell you or predict this next word in the sentence that you're trying to generate. That is pretty much the summarization of what a lot of these AI buzzwords kind of frame into. There's a few different types of learnings. The main ones are reinforcement, supervised, and unsupervised. Just to give you some context to what these mean is, if you imagine you play a computer game the very first time, the first few times you play it, you just die straight away. You're trying to understand the controls, you're trying to understand the levels, like avoid the fire, avoid the boulders, jump over the gaps. So you can give an AI model a computer game and it will do the same. It will play and it will learn and it will evolve. because it's learning the same way you are. And you tell it, you say, look, if you fall down this hole, you're going to lose. You want the point score to go up, and then it will play over time, and it will play thousands, if not millions of hours in parallel. And off the back of that, it can then get better at the game. Supervised learning is where you basically have a model and you want to give it a load of data, and you're going to tell it already, this is spam, this is not spam. And then it will basically then predict the next email you give it. What's the likelihood that it's spam or not spam, for example. And then finally, unsupervised is where you just give it a load of data and you say, find patterns in this mess. This is particularly good for finding vulnerabilities in code, for example. Now, for a long time, AI models worked in what's called classification. So you have an algorithm, you have training data. So in this case, the training data is a load of pictures of cats and dogs. And then the model runs over that training data. Sorry, the algorithm runs over that training data and creates a model. That model then can be communicated to. So you can say, I have a picture. Please tell me if this is a cat or a dog. And it will return back and go, here's a dog, and I'm 70% sure. Or this is the cat, and I'm 0% sure, for example. And that's what a lot of models and a lot of machine learning was for a very, very long time. And so you could argue to this day is still the fundamental principle of what we're trying to do. Then came along these clever little speakers that we put in our houses called Alexa and Google and Siri. And they worked slightly differently because they used a principle called intent matching. They enabled software developers to bring applications, to build services on top. And they would say, we want to communicate to this through natural voice, but to do so and to do so effectively, you need to tell us all the types of ways people are going to talk to you. So, for example, if you were making a shopping app, then you potentially would say, okay, cool, right? So Peter would like to buy 5 bananas, total price is this, is one way that that person may request to buy something. And you would just tag and say, well, okay, so if they say Peter, that's someone's name. If they say 5, that's a quantity. If they say banana, it's a product. And if they say $4.34, then that's a price. And then you would just give the model 100 different variants of asking that same question. And then with a decent level of confidence, if you then asked, for example, I would like to buy 5 bananas for the total price of $2, it would be able to match it and know that you're trying to use this service, which is to purchase bananas, and then would route you accordingly, and the application would be able to understand. And that was good for simple things like turn off my lights, or turn off my lights in the living room, or buy me some batteries on Amazon, whatever it may be. But what we found is as people become more comfortable with using these speakers for controlling homes or music or buying simple things, we wanted more of it. We wanted to be able to interact with technology, with our computing in a much more humanistic way. We didn't necessarily want it to always be right, but we wanted it to not go, I don't know, or I can't understand you. We wanted it to be like us. And then, fortunately, we had this thing called generative AI kind of come along. Generative AI is the idea of generating the next word in a sentence. So you can say, write me a poem on X, and it will take that and it will use its relationships and its knowledge, and it will then basically predict the next word as you go, based on what it already knows and a few other factors. But just to give you an idea and to mirror the previous stuff is you have data. In the case of large language models, that data is a lot. A lot of these models are typically trained, they typically read or consume most of the internet's written text, things like Wikipedia, news sites, Twitter, etc., all that type of stuff, to understand the nuances of language and the different form factors. Once it does that, it feeds this into the model, and it uses this transformer model to consume this information, to provide this level of understanding and the connections and relationships between words. And the reality is that we don't really know 100% how this works so well. All we know is the more information we give it, it seems to predict a much better outcome. Though we might be hitting that ceiling on the volume of information provided. Now that will basically give you a very good understanding across the general populace. If you just talk quite passively and openly and not really ask for too much, it'll work amazingly. You can then fine tune that model within a narrow subset. So for example, let's say you spoke to the model and said, please can you describe or write me a poem on distressed debt. Now it's going to see distress, it's going to see debt, and it's going to think of it as negative. It doesn't know that the distressed debt is a class of debt rather than something terrible. Now you can fine tune that model to understand what that product name is, what that terminology is, which is great. And you can also do it in the space of environmental education. You can teach it to understand things like climate. For example, there is now a climate LLM, which understands the terminologies within that space. You could do one for animal welfare or for terms around the different types of trees or ecological kind of terminologies that exist, just to really hone in the understanding of the words. And then once you have that model, it has been fine-tuned or it has been had human reinforcement, like labeling added to it, you can then prompt, you can then talk to it through natural language. You can ask it questions, you can ask it to write things, and that is the crux of what this large language model thing is. And you're gonna hear a few key terms. The main ones are parameters and tokens. So parameters are basically, I love this example, which is if you imagine a camera, you're able to tweak like the brightest, the focal point, and by moving all these levers, or if you're on like your phone, by moving all these different things, you create the output of the images different depending on how you tweak these things. That is basically what represents these parameters. And then we have tokens, and tokens are the amounts of, let's just say syllables for argument's sake, the amounts of syllables that the model can understand at any one time. So you can give it 100,000 syllables, and that's, so you can say, here's a book of 50,000 syllables, please summarize it in 10,000 syllables, for example. And these are the two biggest kind of terms that you'll hear a lot within the large language model kind of world. Now, the applications for this are more and more each day becoming quite surreal and quite extensive. There's been examples of using these models for prediction. Google released a great one for weather forecasting, where they were able to take like 12-hour window to predict crazy weather patterns. We can use them obviously for creation. We've seen the image generation that's existed across social media in recent years, and also music is becoming quite a fast one. We can use it for identification. So, can you, is this person Lee? Is this person Dave? Is this person Sally, for example? And then optimization. Can we optimize the travel route of our vehicles by understanding, the traffic light system, or how many left turns there are, or whatever it may be? Artificial intelligence has a multitude of different applications across a spectrum of areas, and that's why there's so much hype and excitement about it. And I just want to share with you one example. So at the end of last year, 2023, I presented at COP28 in Dubai, and one of my presentations was on analyzing social media posts within conflict zones, and can, by monitoring the social media posts, because when there is a conflict, unfortunately, people post to social media to obviously shine a light on what's happening, and also as a way to communicate with friends and family. And can you basically use these images that are taken to track environmental damage over time? So for example, you can see here's a photo. Actually, if I show you in detail here, here's the original photo on the left. And then the second image in the middle is a segmentation model. So that's basically just identifying all the buildings or blocks of grass or trees. And then the image on the right is extracting away anything it doesn't deem to be natural in the environment. And then by doing so, we're able to then say at this GPS point, that's what this used to look like on the far left, on the far right. And then we take a picture in 6 months' time, and then we can see the degradation. And also potentially use that for a multitude of other things. For if we then know what if there was a fire or if it was a missile, then understand how that land can be reused or repurposed in the future based on how it looks and how it's degraded over time. Now, all this is well and good and it's quite exciting, but it doesn't mean we can avoid the ethical questions. So copyright plays a massive part in this. It's a massive debate as to, are these algorithms copying other people's works? Are they just consuming them the same way that if we look at paintings, it's going to, and then we decide to paint something, it's going to influence how we do things? That is still kind of up for debate. Like, personally, I kind of lean on the training side of things. Data governance, if you are someone who doesn't want your information to be fed into these models, because if you're using certain products and services that are free, this stuff is very compute heavy. So they're monetizing it some way. So therefore you have to ask yourself, if I'm not paying for this, how are they making money? And therefore, do I want the secrets of my, water data or of my business or whatever, if we think just slightly outside of the environmental use cases at the moment. And then truth. Large language models in particular, they do this thing called hallucinate, which is where they'll just make stuff up. And it's not that they're lying, they're just trying, their reward mechanic is to please you, to give you something. So there is an element sometimes where you can't necessarily trust the results. There are ways to work around this through this idea called truth graphs and knowledge graphs that can kind of mitigate this, but it's just something that has to be bear in mind that if you're giving data about your cause and you wanted to generate a script or a blog post or a report, you do need to fact check the results, because this is a creative engine, not something that's just pulling out raw facts and figures. And then finally, biased. All information has bias to some capacity. The internet obviously is no different. And we just have to remember that when building these systems, that there is bias in it. And again, human intervention to check. And then you kind of have to put your name on it and say, this is, I'll die by the sword on this if that's the way it goes, because I trust and I believe in it. But we'll expand into ethics as we get further on into the generation side of things. It gets quite interesting. So that's the end of module 3. Coming up next is module 4, where we're going to talk to our information. Have a lovely afternoon.